Hello, everyone, and welcome back to another episode of the Space Roundup. Hey, Nick and Terry, how's it going?
Going well.
Nice and warm.
Awesome. If you're joining us from the UK, we hope you've been enjoying the recent heat waves, enjoying the weather, having lots of fun in the sunshine. Tonight, we're back with the latest and greatest of what's happening across the universe. With that, I'll hand over to our guests, Nick and Terry. Hope you guys have another great show.
Thanks very much. It's interesting, Terry. I don't know what you thought. I mean, we chat obviously about what's coming up on the show, but it's been quite a quiet month up until like literally the last 24 hours.
Yeah. Well, there's lots of fairly specialized astronomy news, but not all that much happening on the space sector. But now things are, if you'll pardon the pun, taking off.
Indeed. Yeah. So we've got a packed show. We're going to be talking about all sorts. We're going to start with an absolute belter of a story about filament shielding in the early solar system, Terry.
Yeah, indeed. This is one of those things that everybody knows a little bit about, but we're missing one piece of the jigsaw, if you like. Most people have heard of a supernova, particularly in relation to Betelgeuse, the giant star in Orion, which people are expecting to go supernova sometime within the next million years or so. And we've talked about that many times. But supernovae basically are the events that create a lot of the essential elements that makes life possible on Earth and elsewhere in the universe. But the other side of the coin is they are incredibly energetic, fierce, violent explosions, and you don't want one going off anywhere near to you. Going back to Betelgeuse, it's far enough away that it won't bother us if it does go bang. But supernovae were going off regularly in the galaxy at about the time that the solar system was forming. And if there was one quite close to us, then obviously that would have done a lot of damage. I mean, these are colossal explosions, give off more energy in a matter of hours than the sun does during its entire lifetime. So one of the things that we had often wondered about was what was it like whenever the solar system was forming? And one of the things is that there's both good news and bad news from this story. They do think that a supernova went off relatively nearby as the solar system was forming, when the planets were still in the protoplanetary stage. But the good news was that a molecular filament which we're going to talk about, saved us from the effects of that explosion. Now, most stars, in fact, we think probably all stars, are born in giant molecular clouds like the Orion Nebula. It's one of those things that's visible as naked eye and fascinating to look at in a telescope, where there's hundreds of stars being formed right now at the moment. And within those giant molecular clouds, there are filaments of denser material. And we think that stars with approximately the same mass as the sun form in little knots along those filaments of molecular gas, whereas bigger stars like Betelgeuse itself would form where the filaments cross each other, like a sort of a hub, a roundabout, if you like, in the molecular cloud, where a whole lot of filaments intersect, and that means they then are much bigger because there's much more material there. And they're the ones that live a short, violent, energetic life and go bang. Whereas the sun, we think, has been in existence for about roughly 4.6 billion years, and it's not going to go bang yet. So the story seems to be that there was indeed a supernova that went off in the vicinity of the early solar system, but it was at one of the hubs. And since we were further out along one of those filaments from the hub, the filament itself protected us from the incredible blast, the shock wave from the supernova that went off. So we think that probably we were many I haven't got the figure in my head, certainly many, many astronomical units, possibly light years away from the supernova that exploded. And it would have taken, they reckon, a team of Japanese astronomers that worked on this, about 300,000 years for the blast wave from the supernova to clear away the material in the filament that was between us and the supernova. So the filament from which the solar system formed actually also acted as a buffer, and it protected us in the early stages of the formation of the solar system from the blast wave, which, if it hadn't been protected, would have blasted away a lot of the material, which forms what we call the protoplanetary disk, the disk of material around the forming sun, which contains the material that goes on to form the planets and their moons and asteroids and comets and so on. So, as I say, the supernova is one of those things that produces the elements that makes life possible on Earth, but the filament that was between us and the supernova protected us at just the right time when the supernova exploded. And basically what they found is that material in the meteorites which are in the solar system, which date back to the very early days, the formation of the solar system, contain the isotopes from the supernova. And that shows that the molecular cloud and the protoplanetary disk that was forming at the time absorbed some of those particular isotopes, but they protected us from the blast. So it's an amazing piece of detective work, if you like, and it shows that we were quite lucky in a way that we were had that protective filament at just the right time when the solar system was forming, because of the heavier elements, heavier than hydrogen and helium, had been blasted away by the supernova shock wave, then there would be no possibility of life anywhere in our solar system, certainly not on Earth. So what do you think on that one, Nick?
I think it's fascinating from multiple angles. Obviously, as you said, meteoritic evidence, meteorites, some of the carbonaceous chondrites have got pre-solar grains in them. So we know, obviously, that at some point, billions of years before the solar system took shape in its existing form, something happened in our vicinity that basically shocked that gas cloud into potentially condensing. But then to find out that further supernova have kicked off within the solar system's lifetime, as it were, and we've been essentially protected by this filament, is really interesting. Because the other thing that kind of brings to mind from my perspective is, if you go back to the early formation of the solar system, when the sun obviously became initially active, the dust and gas cloud around its initial formation was blasted out itself, forming obviously the gas giants towards the outer part of the solar system, leaving the denser material in the inner part of the solar system, giving us the Mercury, Venus, ourselves, Mars, the rocky inner planets, and then the asteroid belt. But obviously outside that, we've got the Kuiper belt, the edge-of Kuiper belt, going out through to the Oort cloud at about 1 light year, where a lot of the long period comets come from, for example. And you only have to go back and look at the moon and think about things like the late heavy bombardment as to how common these supernova events were during the early formation of the solar system, and whether or not shockwave events like a supernova in our vicinity were the triggers for things like the late heavy bombardment. We don't know. Was it Jupiter moving through the solar system? Was it differential gravitational issues caused by planetary formation, etc.? We just don't really know. And again, it's incredible detective work that's starting to put all of these pieces together. That's why I find it fascinating, because it really is starting to build a picture of what's happening. And I'd love to see some of the big space observatories that are coming online now. They're obviously seeing already protoplanetary disks. We've been able to directly image exoplanets for quite some time. It's been able to see these kind of processes occurring in other stellar systems. If we've got, we haven't had a decent supernova since 1987 in our own kind of neck of the woods, as it were, and that was Southern Hemisphere. But once we do get a really interesting supernova, not just to look at the supernova itself and the formation of the supernova and how it evolves, which is a common thing that we do with extragalactic and some of the recent supernova, the one in M101, for example, fantastic supernova to watch, but it didn't really give us any close proximity information or detailed evolutionary shell kind of images, which we got with 1987A. But I'd love to see not only what's happening with the shell and the formation, it's what's happening to things around it. If we were to image a star system that we knew had exoplanets orbiting it, that we knew was going to be a potential candidate for a supernova, and Betelgeuse is obviously the big one at the moment. It could go off tomorrow. It could have gone off 100 years ago. We don't know. As we've said many times on the show, it could go off in the next million years. We just don't know. But it'd be fascinating, I think, to see the proximity effects of what happens nearby those, and whether or not other similar kind of things start happening. Kepler, the Kepler Space Telescope, was able to image an Oort cloud, as it were, an ice and water disk around another star system some years ago, and just to be able to see what's happening in those, I think would be amazing. Yeah. And the technology that we've got and the space telescopes we've got is just getting better and better. Yeah. So.
Indeed, if you Google any of the images of supernova remnants, you can see just what the effects are like with that material being blasted out into space at incredible speeds. And not only that, but the actual gamma radiation and other intense radiation from the supernova. You don't want to be too close when it happens.
No, you only have to look at the Crab Nebula, and we've both imaged that and seen it, probably naked eye, well, not naked eye, but with telescopes, with our eyes. And you look at the filamentary structure of that, and I've imaged it over many years, and you can see, especially with larger telescope images, I used to operate the Falks telescopes, for example, 2 meter. You can see year on year, very, very subtle, but you can see the changes.
You can see it expanding.
And that's from a supernova in 1054. And 1987A, the evolution of that and the images from the Hubble in particular of that have been absolutely spectacular, seeing that evolve over time. Monoceros, and there's just so many great supernova remnants out there that they kind of show this fantastic evolutionary structure, as it were, as it kind of develops over time. But anyway, really, I love that story. Brings us nicely on to our next story, which relates kind of to galaxies as well. So this is the European Space Agency's big new telescope. This is Euclid. This has been in planning for many, many years. Was initially going to be launched from Baikonur using a Roscosmos flight, obviously because of the war in Ukraine and various other issues that had to be stopped. So now it's going up in the next few days. Depending on when you listen to this, I'm hoping for a launch of July the 1st, but obviously launch is cancelled. Falcon 9 from SpaceX. So SpaceX not just throwing up junk and Starlinks into orbit, they're actually doing some real science for a change, which is going to be amazing. So what is the Euclid Space Telescope all about? It's essentially, it's what's called a Korsch telescope design. So a multi-segmented, multi-mirror array, similar in concept, I guess, to many other space telescopes, James Webb, etc. It's slightly different design, though, because it's really designed for a fantastic wide flat field. And the idea with this telescope is that at about 0.57 of a degree per hour, so about 1.5 to 3 times the width of a full moon per hour, it's going to start imaging like segments across the entire sky. Now, I say the entire sky, the eventual aim with this telescope over its 6-year lifespan is to image approximately 1/3 of the entire sky, which is a monumental achievement down to ridiculous magnitude. So unlike the James Webb, which is really narrow focused, obviously aimed at going very deep, giving us detailed views of exoplanets, the early formation of the solar system, the galaxy, etc., and the universe, what this is doing is trying to create a map of the entire universe, as it were, to give us a better idea of how galaxies form over time, what the differentials were between where it goes back to, which they've estimated should be on the average survey that it's doing, which is, as I said, over a third of the entire sky, down to distances of around about 10 billion light years away. So not the edge of the universe, the edge of the observable universe that we're getting with the James Webb, but pretty significant. It's going to go deeper in some smaller areas. Again, looking for things like gravitational lensing. One of the things it's looking for in particular is dark matter, and how dark matter and this kind of invisible material, the dark matter and dark energy, which we think makes up about 75% of the observable, or in this case, not observable universe, how that is impacting the light coming from galaxies going through it. And by imaging not only the galaxies and the effects that the dark matter could be having on light behind them, so gravitational lensing, warping, all sorts of distortion effects, what they're hoping to do is build up not only a map of all of the galaxy's positions, and the accuracy on this is just absolutely stupendous. So this is going to be the replacement for, you may have used it, Terry, I know I have, the Sloan Digital Sky Survey data, where, again, you've got this, it's basically like a gigantic map of the universe. It tells you where everything is. So measuring not only with visible light and infrared light, but with detailed spectroscopy to give you that three-dimensionality of the map. So it can say, okay, here's the galaxy. This is how much it's been distorted by, for example, a foreground galaxy bending the light or whatever, but also the distance based upon the redshift from the spectroscopy instrument on board. As I said, it's going to be taking around about a third of the entire sky. So a very, very significant sky survey and a very significant update to SDSS, the Sloan Digital Sky Survey, which was a ground-based observation. And obviously with ground-based observations, even with things like laser guidance, etc., it's really difficult to get this level of accuracy that you would get from a space telescope. Similar to the James Webb, it's going out to a Lagrange point, Lagrange 2, about 150 million kilometers away from the Earth. It's got solar panels for power generation. Obviously, it's a cool telescope, cool instrument. It's got a specific lifespan based upon its fuel reserves, etc. They're hoping nominally for about a 6-year lifespan. It could be extended if the launch goes as well as it did with the James Webb. That gave it a bit of an extra boost, as it were. The telescope's named after Euclid, and any of you remember your maths back in school, Euclidean geometry. Euclid is a Greek astronomer, mathematician, philosopher, who's known as the father of geometry, as it were. I think he was around about 300 BC, Euclid's around. So again, in kind of ESA's great tradition of naming telescopes after significant scientific figures. And it's fantastic to be able to talk about a scientific story when it comes to space and what's happening at the moment, because so much of it is commercial launches. And it's interesting, in the week that European Space Agency are doing this, they've also had a meeting where they've been talking about the hazards of space debris and how they're looking at sustainable space, etc. And it's missions like this that make that so vital, being able to keep space clear so we can launch missions out to L2, etc., and deliver these fantastic telescopes. It's going to be imaging from around about 550 nanometers, so kind of like the hydrogen alpha end of the spectrum, 500-600 nanometers to about 2 microns. As I said, invisible, infrared, and using a spectroscopic instrument as well. I don't know what you think, Terry, but it's one of those, it's like Herschel. Everybody focused on the Hubble and everybody focused on James Webb because, they delivered the pretty pictures. But these survey telescopes are so important to our scientific understanding of galaxy formation of the whole universe, as it were, what's happening with dark matter and dark energy at the moment. These are well observed effects, as it were, but we don't really still have a clear understanding of what's happening. Dark energy predicted to be increasing the acceleration rate of the universe, but again, it's all theoretical at the moment. We know that dark matter is probably there because we've seen gravitational lensing where there's nothing in the way, so unless there's some mysterious black hole or something in the way, something's there. I don't know what you think your thoughts are on this, Terry. It's one of those unsung hero missions, I think.
Yeah, and it's a very important and an expensive one, 1.4 billion euros all riding on one rocket. It's one that has a pretty good launch rate, but even so, I think we'll both be very glad when that gets safely into orbit and on its way to Lagrange 2. It's a big beast, 2 tons and about 15 foot long and 11 foot diameter. which is sort of comparable in overall dimensions to the Hubble Space Telescope, a bit shorter, but a bit fatter, if you like. But as you say, the important thing is that it will give us this map in 3 dimensions out to going back 10 billion light years, 10 billion light years away, and therefore when the universe is only about 3.5 or so billion years old. And mapping it in 3D shows us basically the way matter is moving and interacting with each other, including the dark matter. And I have my doubts about dark energy, but that's another matter altogether.
Yeah,
but yeah, we need to get not just the incredibly detailed pictures that both Hubble and James Webb provide, but a much wider picture to see how the universe moves and interacts with itself on the large scale. And that's what this one will do. So fingers crossed for a successful launch for that one.
Absolutely. And some of the spin-offs of this relate back to some of the earlier discussions we were having about early solar system formation, because with it being such a wide field and such a deep sky survey capable telescope, it's going to be able to pick up solar system asteroids, comets, before anything else could potentially see them, because of the nature of the field of view and the way that it's doing this mapping across vast swathes of the sky on a daily basis. Hopefully, unlike the James Webb and the Hubble, which obviously have very narrow fields of view by comparison, and some of the ground-based sky surveys like Catalina, for example, which have got huge fields of view but possibly can't go as deep or as accurately as this, being able to pick up objects that we may not know have existed, comets in particular, I think again is going to be vitally important as a kind of almost like a throwaway bonus, as it were, with this telescope. So yes, fingers crossed, July the 1st. The Falcon 9's got a really good reliability rate. I mean, love or hate SpaceX as we do or don't. Their reliability is astonishing. I mean, I think they got to, I forgot the figure now, it's in the hundreds of successful launches and landings again. So I can't see hopefully anything going wrong with that. Things have gone wrong on launches, so let's just hope that we just want it to get out there, because SpaceX obviously launched quite recently, and there was a tugboat mission, one of these kind of debris removal, and that tumbled out of control after launch. So the launch was successful, but obviously fairing separation and the mission deployment didn't go to plan. So it's not just launching it on the Falcon and getting it up there, it's making sure that it gets out to its Lagrange point, it stabilizes at that. Then they got 3 months of commissioning on the instrument. Then we won't see any data from this, and this is not open to bids like James Webb, but won't see any data until I believe the end of December 2025. So it's going to be a bit of a wait. But as they say in most things, the wait should be worth it.
I don't think it's quite as complex an operation as the James Webb unfolding.
No.
But still, it has to get out there and it has to work when it gets there. But fingers crossed, as I say. I'm not superstitious. I don't know why I say that. Let's just hope it gets there.
Let's just hope it gets there. Indeed. Absolutely. Right. So on to our next one. So we're tearing through tonight. We're doing quite well tonight.
A lot closer to home. One of my favorite objects, Saturn and the Saturnian system. And it's one of those things that you just love looking at through a telescope anytime. But anyway, on to sort of the nuts and bolts of this particular one. Enceladus is Saturn's 6th largest moon. Quite small, but nevertheless a significant object, about 500 kilometers in diameter. It whizzes around the planet. It's quite close in. The orbital period is 1.37 days. You can see it with a decent-sized telescope. I've observed it many times. And one of the reasons why it's easy to see, even though it's so small, is it's covered in ice, which is quite reflective. And we'll say a lot more about that. So that's one of 2 moons in the outer solar system that are fascinating, because we think with a high degree of certainty that there is liquid water under an icy surface. The other one is Europa, one of the satellites of Jupiter. So coming back to the reason why this is so important. In the solar system, and particularly in the region of these icy moons of Jupiter and Saturn, we have discovered so far all but one of the elements that are essential for life: carbon, hydrogen, oxygen, nitrogen, and sulfur. The other one, in terms of life as we know it, is phosphorus, and it is quite rare and quite hard to detect. And now, in the icy plumes that are coming from Enceladus, which I'll talk about a bit more in a minute, they have actually detected phosphorus. So now we know that all of the elements essential for life exist in the subsurface ocean in Enceladus. Now, if you see the picture there, you can see that the surface is covered with all sorts of weird markings, nicknamed tiger stripes. And what we think is happening is, though, that is where the ice cracks and materials come up from below. Perhaps I should go back a little bit further. Out at the distance of Saturn, how on earth can there be liquid water? Well, it's quite simple. The tidal forces from Saturn, as Enceladus orbits around very, very quickly, alternatively squash and squeeze the shape of Enceladus in sort of opposite directions, if you like. A bit like squeezing a rubber ball makes it heat up. And so although there's no internal heat within Enceladus from, say, radioactive decay or anything like that, the tidal forces are alternately squeezing and expanding and contracting Enceladus creates enough heat, enough energy for there to be this liquid ocean below the surface. The surface is obviously very cold because it's exposed to the vacuum of space. But as I say, they're very, very sure, without being 100% certain, very, very sure that there's liquid water beneath the surface. And now, because they have now detected all these essential elements that are coming out in the plumes that every so often escape through the cracks in the surface, there is a really good chance that there may be some form of primitive life there. Now, we're not expecting to find whales or sharks swimming around, but any form of life existing elsewhere in the solar system or elsewhere in the universe is of absolutely major importance. It shows that life is not unique to Earth. So there's a mission that'll be going out to analyze these areas. JUICE will look at the ones Europa orbiting Jupiter, the Jupiter Icy Moons Explorer. There are also plans for a mission to Enceladus, certainly on paper anyway, to try and analyze in much more detail the material that is giving off from Enceladus, and possibly eventually to drill down through the ice and look for signs of life beyond the surface. So the breakthrough is now that all the essential elements for life are detected on Enceladus. So exolife is one of those hot, sexy topics in astronomy, and it's leaping forward. And this is yet another rung up the ladder, to mix the metaphors.
I love this story in that, I mean, a friend of both of ours, and I've known her many, many years, Caroline Porco. I mean, she's obviously been really pushing on Enceladus, and Michelle Doherty, obviously based out of Ireland as well. Done some fantastic work with some of the imaging and the instrumentation on the Cassini spacecraft. As we talked about in the last show, the Cassini spacecraft didn't really have the full gamut or suite of instrumentation that would enable it to really dig down, as it were, in terms of looking for the potentials for life in these water plumes. Because as you said, Terry, what's happening is this accordion effect caused by Saturn, and we see it in Jupiter, obviously, with Io, where it's more volcanic effects. But obviously, this accordion effect is also happening at Europa, because Europa, having a liquid ocean beneath a thick crust of ice, as it were, is something that, as you said, with the JUICE mission, they're looking to investigate. And ignoring Arthur C. Clarke and pretend no landings here, at some point in the future, I would hope that not only will there be a return to Saturn, you look at those massive success of the Huygens mission in quite a limited scope in that. And I know Dr. Ralph Lorenz at John Hopkins has been planning a Kraken submarine for Titan. It'd be great to see something go back and almost like, I've developed concepts with the company I work with for penetrator type systems, where you can drop in conjunction with several other people who did some fantastic work on this, penetrator systems where you can drop something onto the surface at incredibly high velocities and effectively punch part of the way through. If you were to get a drilling mechanism into that, it's even a very small robotic submarine, as it were, UUV, going underneath the surface, drilling through this ice. We don't know how thick the ice is all over on Enceladus. These tiger stripes, as you said, seem to imply that the surface cracks and then water kind of gushes out. And we're seeing these water geysers. So if we were able to plant something near to one of those that could punch through what could potentially be a relatively thin coating of ice at that point and get subsurface, you only have to look at the hydrothermal vents and Some of the fantastic discoveries people like Dr. Bob Ballard, etc., at Woods Hole Oceanographic Institute have made over many, many decades now, forgetting his work on the Titanic. And we'll come on to that as an analogy here for the next story in a bit. But it's fantastic work that's been done there that shows that you don't need what we thought were the essentials for life, sunlight, certain nutrients, etc. You can get that from hydrothermal vents, and the potential, as you said, if life was seeded on Earth at some point in the past via meteorites or comets, potentially life could have been seeded on Europa and Enceladus, and it would be bacterial. It would be very small. As you said, it wouldn't be whales and sharks swimming about, but probably not. But there could be something there, and that is the absolute fascination. As I said, there's some great science still to be done here. There's also, bizarrely, I don't know if you saw the argument this week on social media with Carolyn and myself against a startup company in Texas who were planning to extract water from Enceladus to take it to Mars. Yep. They were quoting some stupid numbers. I mean, it was like they were saying $1 billion a gallon. It's like, the subsurface water on Mars is there's proven to be liquid water on Mars, below the surface, either in a slush form or whatever. So, you don't need to take it there, but it's the whole, let's take some water, let's get some water from a moon that we've never even landed on, that's incredibly complex, and we've only ever landed one spacecraft at those kind of distances anyway. Then take it off, then transfer it halfway across the solar system, past Jupiter, past the asteroid belt again, and take it to Mars. It's just, people seem to be jumping on this space crazy bandwagon. And apparently when asked what his business model was for this startup that's getting seed funding, that's getting money, so there's an awful lot of very stupid people out there investing in these things. He said, my business model is Elon Musk. It's like, Elon Musk is an entity unto himself. There was a really great article from, I think it was space.com or Space News, that basically said the space race is essentially over because he is such a dominant force now in terms of launch capability. They're pouring concrete back into Boca Chica to repair the pad. They're already gearing up for the next Starship launch. When that goes up, all bets are off in terms of costs and everything else that can happen in the solar system. So interesting. I'm going to go to the chat, and Chris said about the launch of when we were talking about the SpaceX and the spacecraft that was tumbling out of control. Absolutely right, Chris. It wasn't SpaceX's fault at all. Nobody was even blaming SpaceX. They did, as usual, a fantastic job in terms of orbital insertion, getting the spacecraft up there, landing the first stage back down again. It was the company whose platform they were launching that had the problem with the tumbling out of control. But it shows you, and again, this is a mission that was designed as a tug, and there's all these plans for launching missions to remove debris and boost it into different orbits. They can go wrong as well and just add to the debris mess. So
it's now a big lump of debris itself.
Another big lump in its own right. Yes. Now this brings us on to our kind of penultimate stories about, and this one's quite a sad one in that it's got some analogies with events that have happened recently. Now, if you've been watching the news of late, there was a tragic accident just a few days ago, depending on when you're watching the show, where a human crewed submersible, which was designed to take tourists down to the Titanic, and we're talking about 13,500 feet, sadly imploded, it now seems. There was hope for a few days of there being a rescue, and they thought they heard knocking sounds, etc. But the submarine, with all of the people on board, including quite a young lad who was studying at Strathclyde University, sadly perished, and it'd be thankfully instantaneous. If you look at, I work for a company that designs submarines, those kind of massive implosive events, they are literally in microseconds. It's game over. So hopefully these people didn't suffer. But it brought to light the whole issue of regulation with respect to not only things like missions down to the Titanic, which again been taking tourists for quite some time now. James Cameron, not a tourist, but obviously not a professional research scientist, was diving down to the Titanic, not only for making the film, but obviously for his own interest as well, and doing a lot of really important kind of mapping work, etc. And then Cameron himself holds the world record, along with the crew of the Trieste, for the deepest dive ever down to Challenger Deep, which is nearly 3 times the depth of the Titanic. It's proven that this is as complex, if not even more complex in some respects, than human spaceflight and tourist space activities, which are now starting up in earnest. Not only with Jeff Bezos, with his suborbital kind of New Shepard hops, which do go into space. Now we've got Virgin Galactic. Now, Virgin Galactic, this is a long story with Virgin Galactic. The company, kind of the inception, the idea came from a meeting between Buzz Aldrin and Richard Branson back in about 1995, when they were talking about space endeavors, etc. And Branson then asked for a study to be done. Everybody remembers the X-15 of a certain age. You remember what the X-15 was. It was carried underneath a big, B-52 bomber, dropped. This is in the 1950s, early 1960s. Still holds numerous records for fastest rocket-powered crewed aircraft, pretty much. And some of the astronauts were actually astronauts. They went above the Kármán line, got into space in the thing. It's incredible. It's an absolutely phenomenal achievement, and it gave a lot of kind of impetus into the research work that then went on to the space shuttle. Now, Virgin Galactic came about from this, formed in 2004, partnered with a company called Scale Composites. Burt Rutan, genius designer, came up with this really innovative concept for a suborbital space plane. So by suborbital, obviously at the moment there are no kind of tourist trips apart from the occasional one to the International Space Station, which is costing tens of millions of dollars, where people go into orbit around the Earth. These are very short hops onto the edge of space or just above the Kármán line. There's a whole debate with Virgin Galactic because they only go up to about 50 to 54 miles, where the internationally recognized is at 62 miles. The United States say 50 miles, so technically they are getting their astronaut wings. But so essentially you've got the White Knight aircraft, takes it up to about 45,000 feet, drops the VSS, the spacecraft, from the underneath of it. That then basically powers up and into an almost vertical climb, goes up to the edge of space, switches the engines off, and then performs this amazing feather-like maneuver, which basically then allows the Ark to have the people on board, the paying passengers, or there have been test flights recently, to have a few minutes of weightlessness. So, as I said, this goes back quite some time. 2004, kind of the company was founded. Branson was initially targeting around about the late 2008, 2009 period for some of the flights. That didn't happen. Then it was 2010. That didn't happen. In 2011, 2012, we saw just before that the Ansari X Prize taken by Scale Composites with some of their earlier designs, not the one that's now going to take paying passengers up into orbit. Then we had some significant incidents, which is probably, it proves that space is hard. This is the thing, the tragedy that happened in the Titanic. Thankfully, there's been all sorts of reports that have come out now in the last few weeks where people who've been down and said, things like this could have happened to them. They've lost communication, etc. The structure and the whole, with the vessel that imploded was a carbon fiber and titanium structure. So it wasn't really tested, wasn't regulated. They were told about the safety concerns. And this is quite similar to Virgin in many respects. They've been told about safety concerns, all through their production lifespan. 2007, they had an explosion which killed 3 people. Very, very sad event. 2014, there was then a crash. Where the co-pilot, essentially, it was really, really sad that he died as well. And this was during an initial test flight. And it was because this feathering braking mechanism was deployed at the wrong time. So it's really interesting now to look at, again, it's almost like a billionaire's playground, where the people who were going down to the Titanic were paying, I think, £250,000 or dollars for the experience. The cost now on the Virgin Galactic flights, it started off at $200,000, so about £150,000 in today's money. It's now gone up to $450,000 for essentially 5 minutes of weightlessness on a few hours up and down flight. Now, people I know who've been on the vomit comet, as it were, have said, well, you can, if you want to experience weightlessness, you can do that at a much safer altitude, for several minutes at a time, 30 seconds at a time, but obviously over a period of hours, so you get several minutes of total weightlessness for a fraction of that cost. So it's whether or not people see the value in this, and the regulation. As I said, the Federal Aviation Authority have already criticised Virgin Galactic on multiple occasions for the safety record, for some of the safety systems, for not adhering to policies, for going out of their range, which they did on the 2021 flight when Branson was on board. So I'm not sure about the, I don't know, it's more it's the morals of this now, and the kind of desire to do this. Yes, it'd be fantastic to allow tourists. We've explored. In the early days, you'd have Magellan and various other people sailing around the world and exploring. Now we have cruise liners doing the same thing. In the early days of flight, we had the Blériots, Louis Blériot, etc. Flying across the English Channel, and horrendous safety record in the early days of just aviation flight. Moving forward, obviously throughout the history of human spaceflight, we've only had a few significant, and they have been significant, not detracting from the fact they have been significant tragedies, obviously with Challenger and Columbia from the US side, obviously what happened with Virgin Galactic in 2014, obviously multiple issues with the Russians, including the whole crew of a space station. It's going to be interesting. Chris is saying, yeah, the overview very profound, but wouldn't have paid for the experience. And that's the point. It's an interesting point, Chris. You're up there for a certain period of time, and people have asked me many, many times, would I like to go to space? And up until 2 weeks ago, I said, no, but I'd love to go and see something like the Titanic. Now, not a hope. There's no way you get me on one of those, knowing just what the safety record is now that it's all kind of come out in the wash, as it were. Going into low Earth orbit has never really had much of an interest. Somebody said, do you want to go to the moon? Yes, I'd love to. I mean, to do what the incredible Apollo astronauts did back in the late 60s, early 70s, I'd love to do that. I don't know what your thoughts are, Terry, but the cost of human spaceflight and tourism is supposed to be coming down, and yet from $200,000 to $450,000, it seems like it's going in the opposite direction. Obviously, supply and demand, it will come down at some point in the next 10, 20, 30 years, whatever. We'll have hopefully quite regular ones. People like SpaceX can have such an incredible reliability record with the Dragon capsule, with the Falcons, Falcon Heavy, etc., and hopefully soon with Starship. Then the potential for tourist flight is going to be vast. And with SpaceX claiming, I think it's $200 per kilogram launch costs, the cost of putting, the average person into space in the next 10, 20, 30 years is going to come down. It's whether or not, after seeing what happened with the Titanic incident this week, if it's worth it. And that's the thing. This is the thing. Yeah, Chris is also saying one of the passengers was killed on the Titan submarine. And it was a friend of one of the astronauts himself, had actually flown to space on Blue Origin. So there are people who are what you'd call adventurers, people who've got very deep pockets, obviously, at the moment, who are keen to try new experiences, try new things. But is the risk worth it? And the thing is with, the Titanic now, they're saying they're going to stop all tourist trips to the Titanic. If something similar happens with either Jeff Bezos or with Virgin Galactic, you only have to look at Virgin Orbital and the share price collapsed, and then the whole company collapsed within a matter of weeks after the last failure with Virgin Orbit. Virgin Galactic share price shot up by about 38, 40%, and then collapsed by about 20% a few days later. So it's really interesting. You Google Virgin Galactic spaceflight, all you get is people looking at investment and share prices. Is that the key driver? And is it worth it? That's my question.
Just going back to Chris's first point, it's a valid point, but I think if, with the benefit of hindsight, if Bill Shatner had known just how amazing the experience was going to be, he might have paid for it. The whole point was that he was unprepared for just what an amazingly profound experience it was going to be. And I think now, probably, if he had paid that money up front, he'd have said, yes, it was worth it. The other thing is that at the moment, they're just getting this started. They're hoping to have a second flight in August, assuming this one goes okay, and then monthly thereafter. And I'm sure the price will then come down as they get more and more people going, just the sheer economics of putting 6 people up every month instead of having really.
It's not, well, they've got 800
on the list.
800 on the backlog.
Yeah. Anyway, they're all valid points. The interesting thing to me is that the 3 of the crew are actually Italian Air Force people, and they're going up as a commercial venture. In other words, they're paying for their seats, but they're going to be doing proper research when they're there, and it's whatever you can do within a couple of minutes. But yeah, I would go, I reckon. I haven't got that amount of money available at short notice, but if my bank balance suddenly increased by a factor of 10,
if we won the lottery,
I would have a go. Yeah. But if I passed the medical by the time my time came, I might be in a Zimmer frame.
Medical, if John Glenn can, John Glenn can go off in a space shuttle, Terry. I don't know. It's also interesting going. Some of Chris's other points here. People die on Earth every day. Absolutely. You look at the early days of the car, lots of accidents. The early days of aviation, lots of accidents. Things happen all the time. The economics of it, though, this is what's worrying people in terms of Virgin Orbital. The economics didn't stack up, and the business model didn't stack up, and everything started falling apart. They've got 800 people on the backlog. They're also, when Branson first touted this, it was not only for doing tourist flights, it was, as you said, Terry, scientific research, microgravity research, but also launching satellites. Now, how do you launch a satellite on a suborbital flight that isn't even crossing the Kármán line? Point one. The velocities aren't there, so you could get something up for a few hours maybe, or minutes, basically floating around before it crashed back down to Earth. So not really a satellite, but more of a kind of very, very high altitude experiment, balloon type experiment. We see Hubs all the time, launching Lego figures and everything and claiming that they're going to the edge of space. Well, when 30 kilometers is the edge of space, then Swindon is the train station for London. The distances don't add up. It's really, really silly. If you don't know where Swindon is, it's nowhere near London. So when people say, oh, we're going to the edge of space with a balloon, no, they're going at 30 kilometers. Space is 100 kilometers. It's quite some distance away. Anyway, I think it's going to be interesting watching the economics of this, because a lot of people have got very upset as well. It's some very rich tourists, and that's the other thing. People will look at the Titanic accident, and if you're a movie star or whatever, you may be thinking, well, hold on, this is possibly a little bit too risky. And yes, Chris has said there is a market for it. Yeah, obviously there is a market for it. Undoubtedly, there are an awful lot of rich people out there, but it only takes one or two accidents, and the Titanic was the proof in the pudding, and that the arrogance of humanity at the time to say it can't sink, so we're not even going to put enough lifeboats on it, changed what happened there. And I think that's what's almost needed. You need a change in the regulatory system. You need a change in the safety. The safety is going to improve, and it will become more of a regular thing, much like aircraft travel. And the ability to fly from London to Australia in maybe an hour and a half as opposed to 22, 23 hours is really enticing, I think, to anyone. If you can go into an orbital, flight to do that, that's where I think the business model will really start to kick in. I think we're still a few years off from that as yet, unless SpaceX pulls something out of the bag, which who knows, they always can. But I just think it's one of those things that's almost not hit a pause. It's a bit of a pause and a bit of a reset where people have, I think, just started to think a little bit more rather than just getting all excited and carried away and saying, oh, we're going to space, so we're going to the Titanic. It's like when something bad happens, the reset button is flicked, and that isn't a bad thing. I'd say the demand is there. People will still want to go. There's still people climbing Everest, walking past bodies. I mean, you don't pull the bodies off Everest, and anyone who's ever climbed up Everest would have passed at least 30 or 40 bodies on the way up that are just there, permanently sat upright or lying down in the snow. So there will always be that quest for adventure. I think the mainstream commercial aspects of this, I think, are still a little way off. And I'm not saying it won't happen, because Virgin have got a great track record in terms of their aircraft. They've been delivering people all over the world. I've flown on many a Virgin Atlantic flight. They're really good. The train's a different story because they've had all sorts of problems there. But yeah, it's one to watch, I think. That's the thing.
The whole point was that the submersible that collapsed wasn't properly regulated. I think now, before anybody does anything like that, they will have to go through the proper testing, certification, regulating process. And if that is approved, and certainly if there's a bit of competition, then they could start up again. Maybe not to the Titanic, because there's a lot of argument saying that that's actually a grave site. But deep sea exploration, certainly I don't think we've seen the end of it. But,
no. I mean, you'd never pull the plug on the likes, as I said, of Bob Ballard. It's like, these are iconic figures in human exploration, so you don't want to pull the plug on that, definitely. Anyway, our last story, and this is another belter.
A new way for stars to die. Sorry, moving on from one topic where we were talking about people dying on another one, but it's one of those things that fascinates. If you sort of troll the internet, you'll see lots of stories about how the sun will die, when the sun will die, how will we all die. And stars do have a limited lifetime, although some live for a very, very long time, but that's a different story altogether. But basically, up until now, there were three main ways in which we thought we knew that stars could come to the end of their life. Star like the sun basically burns through its nuclear fuel moving up the periodic table to more and more complex elements, much simplified this, but basically it ends its life by swelling up to about the size of, say, the orbit of Mars, throwing off its outer shell, and then what's left basically shrinks down and becomes a white dwarf. And we know of white dwarfs. You can see one yourself with a good telescope, the companion of Sirius. And they basically have, again, probably a very long lifetime, but not from nuclear reactions, just slowly emitting energy simply through the gravitational contraction of the material. They shrink down from the size of the sun to about the size of a city, roughly. So medium mass stars like the sun, although it's officially called a dwarf star, but it's bigger than a lot of others, probably end up like that. Massive stars like Betelgeuse end their life in a colossal explosion. Basically, I'm not going to go into all the detail, we don't have time, but basically they also blow off their outer layers. But the important thing is that at a stage that happens, they have run out of energy because the nuclear reactions to create iron, which is the stage that they reach at that point, that takes more energy put in than is given out. So the star is no longer producing the energy to keep it in this huge distended state, and it collapses on itself and goes supernova, as we were talking about earlier. Other examples that we have seen are where neutron stars, which are a stage beyond white dwarf stars, which quite often form in pairs, they spiral into each other and collide with each other, or perhaps also collide with black holes. And that has given us our best examples so far of gravitational wave events. So there were those three, but they've now come up with another one. And this can take us to something which is very much well worth bearing in mind. You may well have heard that the Milky Way galaxy and the Andromeda galaxy will collide with each other in between 4 and 5 billion years from now. It's not going to be an instantaneous event because they're two pretty big objects. And you might think, there'll be loads and loads of stars colliding with each other when that happens. Well, actually, the chances are very, very slight because the distances between the stars are so vast. It's basically like, say, one swarm of flies passing through another swarm of flies. They don't fly into each other. On average, the distance between stars in our galaxy is a few light years. A light year is 6 million miles, 9 million kilometers. The nearest star to the sun, 24 million kilometers away. So you could get a whole lot of stars passing our area of space, and they wouldn't collide either with our sun or with our nearest neighbor, Proxima Centauri. So even though stars are whizzing around in the galaxy and galaxies do collide with each other, and the spectacular effects that we see are mainly due to gas clouds colliding with each other rather than individual stars. But that's taken over the average of the galaxy as a whole. We're about 2/3 of the way out from the center of the Milky Way. And as I say, the average distance between stars in our part of the Milky Way galaxy is a few light years. Near the center, it is a lot more crowded. And also the stars are moving much, much faster, a bit like the way Mercury moves around the sun a lot faster than the Earth does. The closer you are to your center of gravity, the faster you have to orbit. So near the center of our galaxy, surrounding the supermassive black hole, there's an incredible concentration of stars, all orbiting around very, very quickly. The same would be true of most other galaxies. And they think they have now discovered a case where literally two stars collided with each other. It would be an incredibly rare event out in our part of the galaxy, but in the much denser part near the center, then it can happen. So we think that has now happened. I'm not going to go into all the astrophysical details of how they know, but basically think that two stars collided with each other, and that was a star death. So there are now 4 ways in which stars can die. Just to complete the picture, there are stars that are very small. Red dwarf stars actually have lifetimes so long that all of the red dwarf stars that ever formed are still very much alive and will go on shining for possibly hundreds of billions of years in the future before they run out of fuel, because their reactions happen so slowly. So that's something to bear in mind. If you're in a planet going around a red dwarf star, one of the things you don't have to worry about is that star coming to an end. There may be other things to worry about, but not that. So this is just an interesting addition to the story of stellar evolution and stellar lifetimes. Nick, over to you.
It's interesting because it's almost reminiscent of what happens with a Type 1a supernova, where one star is effectively stripping the other one. So you say about star death, you look at, the general consensus, as you said, in terms of our star will eventually go nice and gentle poof, and nice big shell, looks not too dissimilar to the image you see now, something like Messier 27, which is a really good example of a planetary nebula. You've got the Betelgeuses of this world that are just going to go bang and pop. But yeah, this is an interesting one because, as I said, I've always thought of a Type 1a supernova where some poor star that's sitting alongside another one is basically being stripped until the other one goes bang, and then what's left of that's again going back to the supernova story you're talking about earlier. What's happening with the core of what's left in that one? Because essentially that supernova that occurs on the star nearby, is it going to completely and utterly decimate everything that's left of the star that it stripped, or is there a remnant left over, or is there some material that gets shocked out in that? Who knows? I'm not a stellar astrophysicist as well, so but yeah, it's again, we just don't know everything. That's the thing. It's all new discoveries all the time. Yeah, a new way for stars to die. Who'd have thought that was even a thing up until but then, scientific research is all about that. I'm going to go dive into the chat just briefly. Mike Foylan was asking about Dennis Tito. Yes, it was Owen Garriott's son, as Chris has rightly said, Richard Garriott, who was going to be the first space tourist. Now, Tito launched in about 2001, so space tourism has been going for some decades now. Tito, obviously, I think he paid about 20 million at the time in 2001 to go up and become the first space tourist, as it were. But yeah, Owen Garriott's son. Owen Garriott, obviously famous from his work. He passed away quite not too long ago, actually, on Skylab. One of the Apollo era astronauts. Great friends with the likes of Jack Lousmer and Alan Bean and various other people who flew on the Skylab missions. But yeah, it's interesting now to see who's going up, and who wants to go up. You've raised some interesting points, Mike and Chris, talking about the people. I hadn't thought about who these adventurers are likely to be, going back to our previous story. But on this one, yeah, fantastic. I absolutely love. And if you get a chance for a telescope, or if you're into astrophotography, and we'll talk about this in Look Up, try and spot some of these planetary nebulae. They are fascinating to see, especially Messier 27 at this time of year, really high in the sky, constellation of Cygnus area of the sky. You can't really miss M57, M27, really, really prominent at this time of year. If you've got a good sized telescope, you'll actually see some of the structure in M27, M57 just with the eyepiece to the telescope. If you take some images, what's interesting with M27, as you probably know, Terry, there's a really good exoplanetary star system. Quite near to it, so it's one of those. If you want to know where there's planets going around a star, look at M27 and kind of look off to the left, as it were. Obviously, there's maps you can find online that give you the exact details on the star. I forgot it's an HD classification star, but it's really, really fascinating to look at things like that and think there could be somebody there looking back at us, thinking, "Oh, that star system over there." Anyway, which brings us nicely onto our Look Up at the moment, which is our kind of final section. I don't know if you've been keeping an eye on Venus, Terry.
Yep.
Absolutely spectacular. I don't know what it is. It's just been so. We've had really great skies. We've had some great, sunny days and long nights, very clear nights of late. And just watching Venus, like through midnight, early hours of the morning, dipping down through the haze and the kind of munge in the lower atmosphere and the colours changing. But it's so spectacularly bright. I mean, it's literally shadow castingly bright if you get out to a good dark sky location. But sadly, it's kind of going away from us now.
Yeah, it's what we call the waning crescent phase, like the moon after it's past full and becomes last quarter or third quarter, and then it shrinks down. A shrinking crescent, which is actually a contradiction in terms because crescent literally means growing. So it's shrinking. But anyway, it's about 34% illuminated at the moment. So it's sort of a fattish crescent, but it is shrinking as it moves in towards the sun, and we see less and less of the side of it that is illuminated. So catch it while you can. It's at the moment quite close to the planet Mars, which is very, very much fainter. It moves out almost to, I think it's about 4 degrees away from it, and then Venus's motion brings it back in towards the sun, so it never actually catches up with Mars. But it's interesting to compare the difference. We're seeing Mars more or less as a full phase. I'm working off the top of my head here, about 90% illuminated. Venus only 34% illuminated. Venus obviously a lot closer, but it is, I would reckon, again off the top of my head, probably about 1,000 times brighter than Mars at the moment, partly because Venus is covered in cloud, which is very reflective. But a whole lot of factors involved here. The long summer twilight, the fact that the angle of the ecliptic to the horizon is decreasing for us in the northern hemisphere anyway. Venus will disappear actually pretty quickly within the next couple of weeks, so catch it when you can. If you have a telescope, it's fascinating watching the crescent change shape, and it will become a very, very thin crescent if you can see it in a telescope before it finally disappears. The other thing that I find is fascinating at the moment is something that isn't there, or almost isn't there, the noctilucent clouds. We've had an incredible series of clear nights, but very, very few sightings of this. It just shows you we don't know, even in our own atmosphere, an awful lot of what's going on. We would have expected to see, at least half a dozen reasonable displays by now, given the number of clear nights we've had over the last couple of weeks. But there have been a few very, very sort of minor displays of them. And we talked about them last time, hoping that people would see them. I haven't managed to see any this year yet. And that is amazing for me. Normally I'd have seen a couple of displays of them by this time. Anyway, they're caused by meteoric dust very high up in the atmosphere, being illuminated by the sun when it's well below the horizon, too low down to shine on ordinary clouds in our troposphere. But these clouds are many, 60, 70 kilometers up or so, and they can still be illuminated. And they're beautiful to see, beautiful to film. If you take either a movie or video or a series of quick exposures and run it as a video, you'll see the structure and the movement and the change. Hopefully we'll get some before the end of the summer. You can see them up until roughly about the middle of July.
Yeah, interesting as well. Chris said it's quite funny. United Launch Alliance (ULA), obviously a partnership with Boeing and Lockheed and various other organisations. Their Delta Heavy, which is a monumental rocket. If you ever see that one take off, it's incredible. There's a fantastic video I saw. Somebody put a remote camera on the launch tower, watching that thing taking off as the tower arms were swinging back. It was absolutely spectacular. But yeah, that can create, obviously due to the emissions from it, can create a pseudo noctilucent cloud display just from the exhaust plumes. And some of the rocket launches where you see them and they create these spectacular displays that people phone in and say, oh, I've seen a UFO or whatever. That again is really, really fascinating. But yeah, it's true. Mike's saying you've said you've not seen any. I've not seen any. I've seen a few images, various social media sites. Going back to Venus, one of the other things, if you are into telescopic photography and observations, get an infrared filter. There's a thing called an IR742, so 742 nanometer filter. With Venus in its current crescent phase, obviously you've got a non-illuminated side to it. Now, if you were to take slightly longer exposures of Venus through that infrared filter, keeping Venus relatively high up so you're not punching through as much atmosphere, you can actually image the surface of Venus, because the thermal energy coming off the surface punches through the cloud deck. And I've seen multiple images which show this, and it's really, really, it's a great little project if you've got a good long focal length refractor, so you can get a good detailed view of Venus. So Maxitov Cassegrain, Schmidt Cassegrain, something like a Celestron C8, C11, C14, any one of the old Meade LX series telescopes. One of those, absolutely fantastic for imaging. One of the best images was a MM190 that I used years ago. I had it on review. for a magazine, and taking images of Venus with that was just amazing. Because the other thing is, if you then get either a calcium K-line or a UV filter on your camera, you can then start to see structure in the clouds as well.
Yep.
So you can take these fantastic composite images where you're seeing detail in the cloud structure and the surface, switching between a UV/calcium K-line filter and an infrared filter.
The thing is, the surface of Venus is so incredibly hot, 300 to 400 degrees. So the heat, as you say, will punch through the clouds. You'd be better if you want to try that imaging. You probably can't go there especially, but if you're at a lower latitude, you'll get a much better view of Venus higher up in a darker sky. We're just in a position at the moment now where it's getting very low and you can only see it in twilight. But yeah, certainly well worth going for imaging like that.
Absolutely. Mike's saying it was a recent plan for the USA. USA obviously had the Magellan spacecraft. There's been numerous plans to put high altitude balloons and almost like high altitude aircraft, not to the surface of Venus, but to kind of fly through the upper atmosphere, where obviously the atmospheric pressure isn't where the Russian Venera spacecraft had. I think they had at best a few hours on the surface and almost got crushed out of existence and melted out of existence and acid rained out of existence as well back in the early 1970s. Going on to Chris, JWST, pointing, you don't want to be pointing anywhere to the sun with the they'd shoot you if you tried to do that. Wouldn't be a good idea. Rocket Lab, Peter Beck, that was the one. So that's probably where Mike was coming from. So Peter Beck, they are planning on sending the first kind of commercial, as it were, or kind of amateur probe towards Venus. So that's going to be, again, worth looking at. And I think Venus needs to be explored more. There's so much happening at Mars and obviously the outer solar system. We talked about the Juno mission. We talked about Galileo in the past. We've talked about all the different spacecraft and probes that go outwards to Mars, to Jupiter, to Saturn, and beyond. Hopefully, we're looking at Uranus missions in a not too distant future, because obviously we've not been out that far since the Voyager days. I think Venus, we've got Bepi Colombo that's just done its third flyby of Mercury as well. So Venus almost seems like it's the nearest planet to us, but we're not doing anything there because it's such a terrifying place to visit. So yes, and I think the technology's moved on so much. Going back to the Titanic story, we've got the ability to send a crew down to ludicrous atmospheric pressures. I mean, the atmospheric pressure, or the pressure on that was, I think they said it was several hundred tons per square inch at Titanic depths. And then you go down to where James Cameron was at Challenge Deep, vastly more. It's just astonishing. I saw some of the numbers and just thought, wow. So if we can do that with modern technology, being able to drop something onto the surface of Venus, now that we've detected active volcanism on Venus, which, again, quite a recent revelation, seeing that there are still active volcanoes on the surface of Venus, I think it's one of those things that needs to go back. We need to go back. The Russians have had a great deal of success. The Americans have had orbiters. The European Space Agency have had orbiters. We need to go back to the surface, I think. I don't know what your thoughts are, Terry, but I'd love to see it.
I mean, if you're working for the sort of temperatures you get nuclear reactors and plasma physics and so on, it should be possible. It's getting the instruments to work. I mean, you can produce a casing that will withstand that sort of temperature, but the instrumentation that sends the signal back out, I'm not technical in that aspect at all, but I think that's probably the tricky bit. And of course, you have very strong winds, and the atmospheric pressure is hundreds of times what there is on Earth. So even a slight movement of wind is liable to blow something over.
That's where you almost need the high altitude pseudo satellite in Venus's atmospheres to act as a relay. Because as you said, punching from the surface through that cloud deck with all of the issues that you've got in terms of atmospheric pressure, you name it, it's there. It's just horrible.
And the sulfuric acid rain, basically, that doesn't help either.
That's not going to be good on your antenna. Anyway, so that's us for this month. We're going to be taking a bit of a break in the summer. As we always do every year. This has been going on now since before lockdown. So, for those of us who hopefully don't remember too much about lockdown, go back to that. So we'll be back in September, all being well. I'm going to be having a bit of augmentation myself. I'm going to be having a titanium hip fitted. My second one, so I had one done. It's in late August, so all being well, I'll be off the morphine and stuff by early September when we come back for the show. Have a wonderful summer, Terry. What have you got planned for the summer?
Oh,
nice?
I've already had my major holiday with the trip to Australia for the eclipse.
Yeah.
But the next thing I'm looking forward to, and it'll be before we come back again, the Perseids on the 12th and 13th of August. Highlight of the summer. No moon this year. Amazing meteor display. Put that in your diary.
Brilliant.
Okay.
Absolutely.
Have a good
Latch,
summer,
how about you?
everybody.
What you got?
I'm sorry.
Awesome. Thank you so
Good
much.
plans for the summer?
Oh,
Latch, you got good plans?
yeah, I've got some plans. I've got a family wedding coming up, so I'll be looking forward to that.
Nice.
And yeah, we'll be open throughout the summer actually in Space Store Oxford, welcoming all of our international space fans to Space Store Oxford. And we're actually, you guys were talking about the overview effect earlier on the show, and we are actually launching a new experience in the coming weeks, which is going to be all about the overview effect. So do stay in touch with our social media channels to know and learn what that is about. But yeah, thank you so much to everyone who's tuned in tonight. Chris, Mike especially, having a lot of fun in the chat. And yeah, thank you so much for another great show, Nick and Terry. We can't do this without you. And yeah, hope you guys have an amazing summer, and we'll see you guys back in September.
And it's good night from me.
And from me.
And it's good
Cheers.
night from him.
Have a good summer, everybody.
Take care, guys. See you later.
Bye.
Hasta la vista. Bye.